Up until now, our mathematics has evolved very much around the real number system. The real number system consists of two major families, and they are the rationals. And the rational numbers are all numbers that can be expressed as the ratio of two integers. And so A and B here have to be two integers. So even like the number 5 is a rational number because it can be expressed as a ratio of 5/1. The other family that goes to make up the rationals are the irrationals. And there are certain real numbers that don't fit into the category outlined above here as the rationals. So they are numbers like pi, your surds, square root of 2, square root of 20, and other numbers like the exponential number, and there are other ones as well. So if we were asked to solve x squared minus 9 equals 0, we could factorise this as the difference of two squares, x minus 3, x plus 3 equals 0. So we get x equals whatever makes that equal to 0, which is plus 3, and whatever makes this equal to 0, which is minus 3. So x equals plus or minus 3, which is a rational number, being plus 3/1 or minus 3/1. However, what happens when we want to solve x squared plus 9 equals 0? We can't factorise that under the rational number system, and so we need a mechanism or a family of numbers that allow us to solve that. So hence arises the complex number system, and so these are sometimes called imaginary numbers. Now, before we go through and actually solve x squared plus 9 equals 0, we need to define the number I. So the definition of I is nothing more than the square root of -1. So this implies that if we square both sides here, we get I squared equals -1. So I is equal to the square root of -1. So how could we solve x squared plus 9 equals 0? So we've got x squared plus 9 equals 0. Take the plus 9 to the other side, we get x squared equals -9. And if you take your mind back to how we solve and simplify surds, we take the biggest square number out of here, and that is actually 9. So our next line is to take the square root of both sides. So x is equal to square root of -9. And whenever we take the square root, now we're going to get used to doing plus and minus. And if we take the biggest square number outside the front, we get the square root of 9 times, or we put plus and minus out the front, times the square root of -1. By definition, as we've outlined above, the square root of -1 is equal to I, and the square root of 9 is equal to 3. So that's plus or minus square root of 9, 3. Square root of -1 is just equal to I. So we can check that our answer is correct, because if we square this, we should get back to -9. So let's just try that very quickly. So we get plus 3i squared is equal to 3i times 3i, and that's equal to, multiply the numbers together, 3 times 3 is 9, I times I is I squared. I squared by definition above is equal to -1, so that's equal to -9. So that one is true. If we square -3i, we've got -3i times -3i. -3 times -3 is +9. I times I is I squared, which is a similar result to above. I squared is -1, so we get -9. So indeed, that works. Okay, so in general, we can actually define a complex number and we tend to use the letter Z for complex numbers. Z is equal to x plus I y. So Z is a complex number. It is made up of a real part. So x is the real part of the complex number, and y, not IY, but I, is the imaginary part. And so the imaginary part, IM, of Z would be equal to y. Now x and y happen to be real numbers. And just by way of a few examples of complex numbers. You might have 5 plus 3i, 2.8 minus pi I. So here the real part is 5, the imaginary part is plus 3. Here the real part is 2.8, the imaginary part is negative pi. And we could have 6 plus 0i or 0 minus I. Now these are special cases, as you can see, but still in all they do fall into the category of imaginary numbers. So just in summary again, I is by definition is equal to the square root of negative 1, and when you square I you get negative 1. In general we write complex numbers as a real and imaginary part added together, so it's x plus IY. The real part of this complex number is the x, the imaginary part of this complex number is the y.